Hey everybody, I hope y'all are having a good day. I just wanted to go through some notes with y'all today. We're going to talk about the side splitter theorem. You should have a note sheet that's been printed for you, and it should follow along exactly with what you see in this video. So hopefully I'll be able to be with y'all in this way and still be able to teach you just a little bit. And thank goodness we have Miss Suggs there as the support. I really do appreciate all that she does to help us out. So the side splitter theorem is kind of a cool little theorem, and it really is just a theorem that allows you to set up tons of different proportions so you can solve for pieces of the sides of triangles or the entire side depending on whatever you need. So let's do a little fill in the blank here with this theorem. And what it says is if a line is parallel, Parallel. We had trouble spelling that yesterday, didn't we? If a line is parallel to one side of a triangle and it intersects the other two sides, we're running out of space, didn't I? It divides the two sides proportionally. Okay, so yesterday we did the mid-segment theorem. So this is not the mid-segment theorem. Now this could be a mid-segment, but we don't really know if B is the midpoint. And honestly, we really don't need to know that, and it really doesn't matter. We can still set up all kinds of different proportions, which remember, we did that when we were talking about ratios. So here's what one of these proportions would be, all right? If you know side AC, it is going to make a ratio with, excuse me, I don't know what I just said. I meant AB, AB and BD. So this piece of this side and this piece of this side. So BD goes down here in this box. So AB over BD, so the top piece of the side and the bottom piece of the side is equal to AC over, what do you think? CE. So the bottom part of that side. Forgive me for my messy writing. I'm trying. All right. So in words, what was that? That was the top piece of that side over the bottom piece of that side, wasn't it? And AC is the top part of that side and the bottom part of that side. So in words, that's where we got it from. And notice how that the proportion is consistent. We've got the top pieces on the top of the fraction, the bottom pieces on the bottom of the fraction. Okay. All right. So let's look at another one. This middle one says AB. So let's find that. So the top half of this line, or the top portion, excuse me, make a ratio with AD. All right, so that's the whole side. AD is the whole side. So AB to the whole side AD is going to be equal to, very similarly over here. Okay, so we did the top half over the whole part, didn't we? So this was the top part over the whole side. So we've got to do it similar. So over here, the top part is AC. And what is the whole side of this triangle? That is AE. So that is another proportion, okay? So again, it was just the top part of that line, or segment, I should say, and then to the whole. All right, there's another proportion. That's pretty cool. All right, let's see if we can get rid of some of this and do another one. All right, the last one is BD. So this is the bottom half to, once again, AD, the whole. So now I've got the bottom piece on the front with making a ratio with the whole side. So what would you anticipate this ratio to look like? If you said CE, you're right. All right, it's the bottom portion of that side, and we need to make it a ratio with what? The whole side AE. Woo, kind of messy there. I'm sorry. So that is an A. I have a new toy here. I'm trying to use it, and it's kind of tough to write with. Okay. So if you need to, let's pause this video and just have a little time to digest and ask any kind of questions you might have. All right. Hopefully you were able to maybe digest that a little bit more, and if you had a question, you were able to get that answered. So what we're going to do now is we're just going to do a couple of examples. And the key to really doing these examples is just to know how you can set these ratios up. All right, so you kind of have to look at how the triangle is set up to know what to do for your proportion. So when I look at this triangle right here, I'll tell you what I see. I see a little top half and a bottom half, a top half and a bottom half. And I say half, but it's not a half. Y'all know what I mean. The top piece and the bottom piece, and the top piece and the bottom piece. And we're trying to find X. So I think this looks a lot like this very first ratio we wrote, which is the top portion over the bottom portion and the top portion over the bottom portion again. So let's set up this ratio. And we're going to solve it for X. So once we get it set up, it's kind of the easy part. All right, so the top part would be, let's do this. Let's write it in terms of the letters. We're going to do AE over ED. That's equal to AB over BC. According to the way this is labeled, that's what that would mean. So let's just plug in what we know. So that's 24 over 10 is equal to 12 over BC, which is X. All right, so now it's time to just do a little math. So 24 times X is 24X. And then 12 times 10, that's 120. Divide both sides by 24. This is old stuff. You should feel pretty good about that. And I think I know what this is, but I'm a little scared to say before I test it in my calculator. So let me do that right quick. So 120 divided by 24 is 5. That's what I thought, but I just wanted to double check. Wouldn't be good to make a video and not have a wrong answer, would it? Okay. So pause the video if you need to ask Miss Suggs any questions or ask your friend a question. All right. All right, time to do example number 2. So again, let's kind of look at what's going on here. I see the way this is set up, we've got an entire side of this triangle and this one. And then we know like just these little bitty pieces. Now we know something about these two lines right here, but honestly, y'all, that's just information there that you really don't need. It's kind of there to throw you off. So we haven't talked any about these sides and how we can use that to write proportions. So we're just not going to pay attention to that information right now. Okay. All right. So when I look at this, I think this is reminiscent of one of the ratios we just wrote up here, either the second or the third one. Oh, it's the second one. Okay. So we've got a ratio where we've got the top portion to the whole. So the top to the whole. So what I mean by the top is this right here. That's what we want to find. So if we did that ratio of WP to the whole side, which is WU, that should equal this top portion, which is WQ, to the whole side, which is WV. Alrighty, so let's plug in our numbers and then let's try to solve here. So WP is our unknown, WU is 21, WQ is 22, whoop, and WV is 33. Okay. All right, so a little cross multiply and solve. 33x is equal to 21 times 22, and that is 462. Then we want to divide both sides by 33. Whoop. I don't have the best writing on this thing, do I? So X is, in fact, 14. Now, does that sound reasonable? Let's just double check. You know, if that side's 33 and that piece is 22, does it make sense If this side's a little shorter than that one, that this piece should be a little shorter than that one? Absolutely it does. And I'm confident in that answer because it seems reasonable. Okay. Once again, pause the video if you need to do some digestion or ask your friend any questions. All right, let's look at this very last one. Now, this one I'm going to tell you is going to stretch you just a tad, okay? Right here, I see an entire length of this triangle. I do not see a length over here that tells me the entire length. Then I also see just this portion is x, that portion is x plus 12, this portion is 11. I don't know anything about that piece right there, but I think I could find it. So I honestly think there's probably two different ways you could solve this. If this whole side is 33, how big is this piece? 33 minus 11, what's that? Is that 22? I think we can get away with that. Okay, then look, y'all. Then we're doing like one that we did earlier. It's just the top to the bottom and the top to the bottom, right? Yeah, it's just one of those again. So here we go. Let's set it up. We're going to do x over x plus 12. Now, I don't have side links on this one, so that's why I'm just rolling with it on this. And then we need 11 over 22. Now, again, I think there's more than one way you could solve this. I think this is definitely the easiest route, though. All right, so 22 times x is 22x. Oh, we're going to have to talk about this one. All right, so 11 times the entire expression, x plus 12. You can't just do 11 times x, y'all. It's 11 times both. So what do we got to do with that 11? Distribute. That's right. So that's 11x. Now, 11 times 12 is 132. So you have to distribute 11 to both of those. And y'all are good at algebra. Let's just do it, okay? All right, now we've got x's on both sides. Let's get x over here because that 132 would be okay by itself. 22 minus 11 is 11 all day. And then these are gone. That equals 132. So if you divide both sides by 11, you get what? You get 12, right? Didn't we just do that a minute ago? Okay, so 12 is your missing piece. Actually, that is your x value. And I could ask you more questions about like what do certain things equal, but I think that's going to be sufficient from here. All right, so let's do this. Let's kind of survey what we're doing here. This is your assignment. It's on the back of the page. I see questions that look very similar to the ones that we've done on 1 through 3. I think that also 4, 5, and 6 should be pretty doable. Yeah, I think they are. All right. And then there's some pretty colorful ones down here. I think that'll be good as well. I think some of these here at the bottom may be a tad challenging. What I will do is I will make an answer key and I will send that over to Miss Suggs so she can help y'all get through these and check your work. Okay. But please be sweet. Please do your best. I will try to check in with y'all in a Google Meet shortly, either today or tomorrow, and I'm ready to be back with you. I'll get there as soon as I can.